Welcome back to our third and final segment. We're still looking at solving circuit problem. Now we want to focus our attention on another circuit that obviously is different from the previous one. And as we've mentioned earlier, that every scenario or every situation is unique in its own special way. So be careful with the familiarity thing to say, oh, I've seen this before. There is always something that would differ from what you are familiar with. But read the question with an intention to understand it before even attempting to respond. Now let's look at the last question, which says, in the circuit alongside, okay, the circuit is given, the resistance of the 6-volt battery and the connecting wires are negligible. So it means that this 6 volts is actually the EMF of the battery, okay? It's actually the EMF, okay? Because we are saying that the battery has negligible resistance, so it doesn't offer any resistance to the current flow, okay? Switch S is closed, okay? There is our switch S. If the switch S is closed, we are told that the current in the 6 ohm resistor is 0.6 amperes, okay? So the current that goes to this resistor is equals to 0.6 amperes, right? So is that the total current? Definitely not, because part of the total current goes to the 4 ohms, okay? And immediately we are thinking, oh, okay, 4 ohms is lesser than the 6 ohms. It means it will receive a current some current that is greater than that of 6 ohms because it has lesser resistance. In other words, we are saying current for 4 ohms is greater than the current for 6 ohms. Why is this true? Because V across 4 ohms, okay, is equals to V across 6 ohms. Why? Because the two resistors are actually connected in parallel, okay? The only thing that's going to differ is the current, because we're saying this parallel combination of resistor is actually a current divider. Now the question says, calculate the current passing through resistor X. Okay, we want the current that passes through resistor X, right? Okay, so now the question says to us, calculate the current passing through resistor X. We know that the current that passes through resistor X is actually the total current, right? So if that's the total current, which is equals to, so the current for resistor X is equals to the current that goes through 6 ohms, which we have, plus the current that goes through 4 ohms. Why? Because these two are actually connected in parallel. They are current dividers. So we can find the voltage for 6 ohms, which is equals to the voltage across the 4 ohms, right? So V across 6 ohms is equals to the current across the 6 ohms, okay, through 6 ohms multiplied by the resistance, okay? So the current for 6 ohms is 0.6 multiplied by 6, okay? This will give us typically, which is our V1. V1 is actually the V parallel, okay? So if we go to our calculator, okay, 0.6 multiplied by 6, right? It gives us that value, which is 3.6 volts, right? So V1 is equals to 3.6 volts. In other words, V across 4 ohms is the same as V across 6 ohms, which is V1, right? Now, we can then find the current that goes through 4 ohms. So the current that goes through 4 ohms, okay, is equals to V1, okay, divided by R, okay? So our current for 4 ohms, okay, the current that goes through 4 ohms is effectively equal to V1, we've managed to get that 3.6 divided by 4, right? So the current for 4 ohms takes us to, if we go to our calculator, right, that is 3.6 divided by 4, right? This is 0.9, right, which is the current that goes to 4 ohms. And you'd realize that 0.6 is for 6 ohms, and then 0.9 is for 4 ohms. And it says to us 4 ohms has lesser resistance. That's why it gets greater current. So the total current that goes through X is equals to 0.9 plus 0.6, which means the total current for X is equals to 1,5 amperes. So this is typically a multi-step type of a problem. Right, let's go to the follow-up question, which says calculate the current passing through the 4 ohm resistor. We've actually done that, okay? There are many ways to do it. So the current that goes through the 4 ohm resistor is actually equal to the voltage across the parallel combination, which is the same as the voltage across 6 ohms, which is actually V1, okay? Divided by that resistance. So we got that resistance, that voltage to be 3,6, okay? So that voltage is 3,6. So this is 3,6 volts, okay? So if that is 3,6, which is exactly the voltage across 4 ohms, all right? Okay, so this is equals to 3,6 divided by 4, okay? This is what gives us the current that goes through 4 ohms, which is equals to 0.9 amperes, right? So it's a simple thing. If the total current is equals to 1,5 amperes, and then the current that goes through 6 ohms is equals to 0.6 amperes, then the current that goes through 4 ohms is equals to the total current minus the current that goes through 6 ohms, okay? This will give us exactly that, right? Okay, moving along, now we want the resistance of X, right? Resistor X is of a known resistance, but we know something about V2, okay? Now we know that the total voltage in this circuit, okay, V total is split between V parallel, okay, plus Vx. So this V parallel is your V1. So V1 is the voltage across the parallel combination of resistors. So if the battery has negligible resistance of 6 volts, this is the terminal potential difference, which means it's 6 is equals to, we've calculated V parallel, which is 3,6, right? And then plus V across X, okay? So V across X will actually be 2,4 volts, right? So that's what we know already. But we want to calculate the resistance. We know the total current passes through resistor X, okay? So Rx is actually equals to V, okay, 2 divided by the total current in the circuit, okay, which goes through resistor X. So Rx reduces to, what is our V2 in this case? Our V2 is 2,4, okay, divided by the total current in the circuit, which is 1,5. Okay, then we can take that to our calculator. Okay, it's a 3-mark question, formula substitution and answer. So it's 2,4 divided by 1.5. Okay, okay, then we need to divide that. Okay, let's delete. Divided by 1,5. Okay, it's actually 1.5. Okay. Make sure that the values that you enter is correct. So the resistance of resistor X is actually 1,6 ohms, right? So resistor X is a resistance of just to confirm that, 1,6 ohms, right? 1,6 ohms. That's the magnitude of resistance, right? Okay. So there are also many ways of actually doing this, okay? But this is one of the obvious ones. And then the last question says the 4 ohm resistor gets hotter, okay? Think about energy, okay, than the 6 ohm resistor after a while, okay? Explain this observation. Why does the 4 ohm resistor get hotter? We have discovered that if 2 resistors are connected in parallel, the one that has got the smallest resistance receives the most current. As a result, this if the 4 ohm resistor and the 6 ohm resistor were light bulbs, which one of the two will burn brighter? If the one that's going to burn brighter is the 4 ohm resistor. What does it mean? It means that this 4 ohm resistor actually transforms a lot of electrical energy compared to 6 ohm per unit time. As a result of that, it gets hotter and hotter. This is a question that actually relates to something about power. So think about power in terms of I squared R, So if you're saying the power that is dissipated by a device equals to the square of current times the resistance. So remember, the one that has got the smallest resistance will actually burn brighter, meaning that it transforms a lot of electrical energy into other forms per unit time, which explains why the 4 ohm resistor will actually get warmer quicker than the 6 ohm by comparison. Okay, so these are some of the, the concepts as an example, that we used in trying to address how we solve problems. We certainly hope that the discussions are fruitful and you try and locate the concepts and understand how these ideas that we discuss in isolation, how they come together, and we can apply the right strategies, use the data sheet, also get some confidence in as far as answering the multiple choice, because this requires a lot of practice, until we kind of get used to it. So because of time constraints, that's all that we have for today. From myself, it's cheers and bye-bye for now.